It's great to see people eager to get going. I know we're eager to get going as well. So give us a couple more minutes and we'll be able to get started. Thanks. Welcome everyone who's logging in. We're going to take a few more minutes here to get started. I think that we're excited to be back for day 2, and my co-host and MC Ashley is joining us now as well. If you want to say hello, good morning, and good afternoon, depending on where folks are.
Yeah, thanks for joining, everyone. Excited to kick off day 2.
Awesome. Well, I know that we still have a couple more minutes. I know I keep saying that, but perpetually a couple more minutes. Just getting the live stream going now. And I know yesterday I noticed that if we waited a couple minutes past the hour, then it helped give more folks a chance to log on. And you know, this event for this week is all about large scale usage of open infrastructure software, as it says on the screen here. And yesterday we learned a lot about upgrades. We heard from some amazing users. And in a few minutes, actually, we're going to ask Jonathan Bryce to come back and give us some of the summaries and highlights from yesterday. I was going to ask, actually, are there any folks who've logged in today that were not on yesterday's session? I know some people are picking the days and topics, so be curious to know if we have anybody here. If you want to put in the chat, the text chat box in Zoom, if this is your first day at OpenDev, or if you're coming back for day 2. All right, looks like Stephen is here for his first day. So welcome to Stephen. This is great. We have a lot of folks that are coming in for the first time, and you know, I think doing these events virtually is a new experience for us. It's allowed more people to be able to join. I think, you know, we saw in the statistics we had people from over 70 countries register, which is incredible. And you know, there's some trade-offs of doing a virtual event, but there are so many benefits, and the ability to kind of pick which day you want to tune in or which topic is a great thing. What do you think, Ashley?
Yeah, Mark, we've got a lot of great ones. I don't know. I think one of my favorites from yesterday was the user stories. That was a great session.
Yeah, in fact, just to mention for those of you who weren't on the event yesterday, we did live stream it to YouTube. We're doing that again today, which means that there's a recording available on YouTube of those sessions. So if you want to learn about Blizzard and what they're doing with some of their massive games and running it with open source infrastructure, you can listen to that. OpenInfra Labs, which is a collaboration of folks from that provide cloud services to some of the biggest universities, Harvard, MIT, UMass, and so forth. They have an exciting cloud that they've built and they've been working on for years, and it's a collaboration, so you can actually help them and then help and you know, be a part of that team. It's an open team you can join, OpenInfra Labs. And then Verizon, Beth Cohen, who's a frequent participant and contributor to a lot of these OpenDev events. She was part of sharing the Verizon story, and she's also moderating a panel. And I see her on the logged in here. She's connecting right now. This is great, perfect timing. So Beth is right on time. Okay, so let's see how we're doing on time here. It looks like we may be ready to kick off with our slides here. What do you think, Ashley?
Yeah, I think we are getting close to that time.
Okay, So I guess we should introduce ourselves.
Probably a good idea at this point.
So I'm Mark Collier, the COO with the OpenStack Foundation.
And I'm Ashley Ferguson with the OpenStack Foundation.
All right.
We will be your MCs today.
What's that?
I said, and we will be your MCs today.
Oh, yes, we will. We will. Excited to do it again. Yeah, so this event, OpenDev overall, is about open source and people using it for infrastructure. It brings together developers and operators and really helps to understand what the gaps are. And it often kicks off a series of work that happens for weeks and months after that. So it brings people together to connect, share ideas, and then work together really as a community moving forward. So it's a great opportunity for that. And then this first OpenDev event, which is this week, the 3-day event, is focused specifically on the topic of large-scale open infrastructure software. So we're kicking off day 2.
We are, and I think we're going to get a little bit of an overview from yesterday in just a second.
Yes, that's right. So our next our next topic is we're going to be inviting Jonathan Bryce on to walk us through a little bit about what we covered yesterday. I think it's always helpful as we enter the second day to remember what we covered, and especially for folks that weren't able to attend yesterday's event. So are we, Jonathan, are you ready to go?
I am ready to go. However, I need just a minute because
Sure.
It looks like the Zoom upgrade removed my screen sharing privileges. So.
Oh man, you know, we have a section about tooling today. It's one of our 3 topics. I don't think it covers permissions for Zool, but there may be some other permissions war stories that we share.
It might cover permissions for Zool, but probably not Zoom.
Sorry. Yes. Freudian slip. Zool, not Zoom. Yes, we have a lot more Zool experts than Zoom experts, but we're quickly ramping up on Zoom as well. Great. So yeah, I think let us know, Jonathan, if we need someone else to share the Etherpad.
Yeah, that's probably the quickest. Aaron, I think since you're currently sharing, do you think that you could share the upgrades Etherpad from yesterday?
Yeah, give me just 1 minute to grab it.
Okay. I just sent you the link, so.
Perfect.
Yeah, we had I guess Zoom, if you're on a Mac, apparently they had an upgrade and overnight on us. So it's always tricky.
We should be.
There's something ironic here that we're trying to show the upgrades notes from yesterday.
Yes, upgrades are hard.
And are being stymied by an upgrade, yes. Okay, cool. So, so yesterday, as Mark and Ashley were saying, we had a couple of great sessions. We had the user story presentations and Q&A, and then we had a moderated upgrades discussion that Belmiro led. Aaron is sharing the Etherpad from that discussion, and there's lots of info in the Etherpad. Maybe if you scroll down to like line 80 or so, yeah, somewhere around there. So for those of you who haven't used Etherpad before, this is a tool that we make extensive use of in our different projects and meetings, and it's a collaborative editing tool. And the rest of the discussions today and tomorrow will be like this one that you're looking at here. Usually the moderators kind of create a framework, and then everybody jumps in and adds notes. So if you want to contribute something or ask a question or you know, participate in the note taking, then this is a great place to do. And then we have all of this great information, you know, after the event to go back and look at. So, you know, I was in the session yesterday and I thought it was really useful. And then this morning I went back through the Etherpad to kind of pick up on what I thought were maybe some highlights, and maybe also even some things that we could think about as follow-on activities coming out of this event. A few of the things that stood out to me, it seemed like in the discussion and also in the notes, people noted I think they called it a turning point in when upgrades for OpenStack became more realistic and more easy, and that was in the kind of Mitaka Newton timeframe. So, you know, if you're on a later version than Newton, then that's good news if you're looking to get to more current versions. If you're on an earlier version, then I guess it's bad news and good news. You know, bad news because you're still there, but good news because once you get to a more recent version, then all of the OpenStack upgrades seem to be less trouble. Something else that I think we heard a lot of good discussion around was pointing out how you know, an OpenStack upgrade is not just an OpenStack upgrade. Lines 86 and 88 in the Etherpad talk about how there are drivers and plugins from vendors and from networking systems, and also other ancillary services that are affected by the upgrade and have to be ready to go as well. So I think that that was something that was talked about, and there are some more notes down below that in terms of what to take into consideration there. Within OpenStack itself, it seems like a strategy that a lot of people incorporate is not necessarily to do everything all at once, but to kind of update key components and then keep all of the components sort of within a n-1 or n+1 release differential between all of them. And the other highlight that I would say came out yesterday is that there are a lot of tooling choices that people are making as they manage the life cycle of their OpenStack environment. So things like Puppet and Ansible, as well as looking at containers and perhaps Kubernetes or Airship or some of those types of tools. It seemed to me like there were a lot of different ways that that people approach that. There was some discussion around current challenges. I think that seemed like a couple of the things that stood out there were it's a challenge to do no downtime upgrades, especially on the API side, and that seems like that may get back to everyone's favorite queue service, Rabbit, the old Rabbit MQ. On line 114 of the Etherpad, there's a reference to a bug fix in Oslo that actually helps with rolling upgrades for Rabbit. So I hadn't actually gotten a chance to check that out yet, but that's something that may be worth looking into. And then in terms of where the difficulties lie, Nova and Neutron together seem to be the projects that were identified as the most challenging, while Keystone and Glance were given props for being pretty easy to upgrade overall. So the last thing that I'll hit on, if you go to line about 116, this is a section that talked about a lot of, I think, really good strategies for kind of planning, validating, testing, and upgrade before it's implemented. And there are specifics around, you know, making a dump of your production database and running all of the database migration in a dev environment, timing that, seeing where it might slow down or where there might be challenges. You know, techniques like pulling, having upgrade rollback and plans and precautions in place. And as I was reading through this, it seemed like there were a lot of different people who kind of had some input to provide here. So maybe one of the things that we can circle back at the end of the week is what are some of the work items that might be worth getting people to team up on after this event is over. Perhaps there's a document about kind of upgrade planning and testing and rollback for OpenStack environments that we could get all of the people who were in the discussion here to contribute to. It seems like that was something that was really valuable and got into a lot of good detail. So that stood out to me as maybe an opportunity to add to some of our existing documentation. So I think it was a great discussion session yesterday around upgrades, and we have more of those today. So I'll hand it back to Ashley and Mark to talk about today's program.
Awesome. Thank you.
Thanks, Jonathan. All right.
So I think Ashley's going to share.
Yeah, so now we are going to kind of cover most of what we covered yesterday, but just for those of you who are new and just as a refresher, we're just going to cover just a little bit of how to participate in OpenDev today. So we're going to share those slides in just a second here.
So I think you're sharing those, Ashley, on your end. There.
Yep.
Awesome. Yeah, I think it was great to see the recap through the eyes of Etherpad, because that's so much of the experience, these events, whether they're in person or online, the Etherpad is where the collaboration happens. So it's great to see that. All right, go ahead, Ashley.
All right, so how to participate. So event tools, obviously Zoom, you've made it here, congratulations. It's clearly got its own challenges that vary by the day. So if you made it through the update, great job this morning. We're here, we made it, so let's roll. And then we have Etherpads. Jonathan was just scrolling through one of those. We'll talk a little bit more about that later. So if you have a question, drop it in the Zoom chat. That's one of the main methods we want to use for asking questions and flagging things to the moderator so that they can pass things to whoever's speaking and kind of stay on topic with what y'all would like to discuss. But also we want to hear from you. So feel free to unmute yourself, jump into the conversation and collaborate with us. So also that means that, you know, we have 100 people on, so we want to make sure that we're all muted when we're not talking, just to cut out on background noise and all of the fun things that come with virtual conferences. So back to Etherpads, you saw Jonathan on one earlier. So most of you have probably used an Etherpad by now, especially if you were on yesterday. But that's just an open source tool that we use for real-time note-taking, feedback, and action items that we want to share with each other and save for later too. And so with these conversations, just to make it a little bit easier for the moderators to know who's interested in speaking, something that we would recommend that you do is in the participants list, when you write your name out, first of all, we'd love if you would include your country or your company, wherever you're from, so we know, put an asterisk at the beginning of your name so that we know that you're interested in jumping into the conversation. And then if you're interested in connecting with people after the event or during, please add your contact information right next to your name if you're comfortable with somebody reaching out to you. And if you need help at any time during the event, feel free to open or email the events@openstack.org email. We have people waiting. If you have login trouble, Zoom trouble, let us know and we're there to help. And then as always, ask any of your topical questions in the Zoom chat, and we will be monitoring that. And then there's also the handy tips and tricks Etherpad that we provided via email to you before the event. And as a friendly reminder, this is an OSF event, so we do abide by the OpenStack Foundation Community Code of Conduct. So please be courteous, conduct yourself professionally, and let's respect each other. And if you need to report a violation of that, you can go to that link at the bottom, openstack.org/code of conduct, and that'll have instructions on how to report it. And then I will hand it back to Mark to give a shout out to our programming committee.
All right. Yeah, this programming committee worked very hard to help us curate and select these different sessions within the larger theme of large open source infrastructure. And so I just want to thank them once again, you know, Allison, Belmiro, Beth, Masahito, and Roman. They've been really, really involved in this event. So thank you again to our programming committee. Let's give them a shout out on Zoom if we'd like in the chat. Then next, I'd like to thank our sponsors. So we have a number of companies that really provide financial support, and those companies make it possible for us to put on this event. And if we could advance the slide, then I can point at the logos on the screen, Ashley, and then we can give them a shout out through the magic of logos. So we don't bombard our event with logos because it's really about the people and the software we're running, but these are the companies that make it possible. So thank you to the companies that provide support. So next I want to go through the schedule for today. So we have 3 topics within the overall theme for this week, which we're diving into today. And we have some amazing moderators. John Garbett to start with. He's going to be talking about tools. And I did a little digging on the Etherpads ahead of time, which I recommend if you want to get prepared for these events. And the tools, folks, this conversation kind of breaks down into a number of different areas. So there's kind of the passive tools for observing, monitoring, understanding what's going on in your environment, alerts. There's the more active tools that can actually make changes to the environment, and then really a discussion around tools that affect performance. So measurement, benchmarking, helping you scale. So those are kind of the broad categories. And then we get into the high availability networking, talking about all the different ways you can achieve that, software level, hardware level, different areas in the software stack. Networking and HA is quite complex, and there are a lot of ways to approach that. So Beth is going to join us and moderate that session. And then the software stack looks at kind of the full stack, not just everything at the cloud or infrastructure layer, but some of the applications that sit on top and the implications of that. So an amazing schedule for today. And we're really excited to kick that off just in a few moments. And then for the rest of the week, meaning tomorrow, we have a bare metal, which is a really hot topic these days, and then edge computing. And then we also have a scheduled block of time to wrap up for the week, go back through lessons learned, where we want to connect next, and then we'll go from there. And we'll have Terry and Jonathan will be helping us with the wrap up. All right. So with that, we want to go ahead and jump into that tools session that I was just telling you about with John. And I hope I didn't steal his thunder with his topics, but it's a great thing about the Etherpads. You can get a sneak peek and get prepared early. So John, I'm going to turn it over to you.
Thanks, Mark. No, that's good thunder stealing. It's all good. So we've laid out some ideas to help us drive the conversation, just give people ideas of how to jump in. Feel free to just jump in with what comes up. So yeah, what we're suggesting is we sort of have a look at observability tools, then look at tools that make changes, and then go through sort of kind of like discussion on looking at how you deal with scale problems when they crop up, given we've spoken about those other sets of problems. And then I wanted to try and go about ways that we can help each other, like share tooling and share that kind of workflow. Excellent, got the Etherpad up. And move on to that. So yeah, feel free to, as you said, put your name in the participants list. I think we're just free to unmute if you want to join the conversation as well for this one. So yeah, let's get going. So I should probably introduce myself first, skip that bit. So on IRC, I'm John the Tuber guy, if you've met me on IRC before. I'm over in Cambridge in the UK. I currently work with Stack HPC, doing loads of stuff on HPC and OpenStack and scientific computing. I started work on OpenStack in December 2010, which doesn't seem that long time ago until you start counting. And that was starting with Citrix, and eventually was working at Rackspace Public Cloud for a little while. Became Nova core reviewer as a Nova project technical lead for a little while. But yeah, most recently thinking about scientific computing and things. But welcome everyone. Do feel free to catch in. So observability tools. I don't know if people want to go through some interesting things. I guess what we'd had some questions to sort of think about in each of these sections. So in the topics, you can see, I was kind of thinking if you want to share interesting horror stories that make you think about the topic and ways that you've come over these things. Sort of thinking back to the Rackspace Public Cloud days. In the early days, it was, the scary thing was people were complaining and we hadn't discovered it first. And then you have to go in and dig. So the more ability to see into things, you can got a lot easier. I don't know if someone wants to take first go.
John, did you ever have the experience that in a post-mortem you changed what you observed and it actually saved you from having the same mistake twice at Rackspace?
Yeah, I was going to say one of the things. So I mean, most of this in my head, I was thinking about software tools rather than process tools. But one of the good kind of things is that you try and get onto this virtuous cycle, where I think it was really important to me that we could change and update the observability as we decided that there were other things to look at. So if when you dig in, you're going, I want to really raise that metric higher next time. One random example, I do remember that we were looking into like how fast VMs could start, and we were actually tracking in OpenStack notifications how long it took to get from like one service to the next. It turned out with cells, you could actually see how happy the database was for how quickly it got from the top cell down to the child cell. So when I knew that when that metric went high for one particular subset of cells, you could see that there was a problem there. Like one interesting observation. So there's a lot about, yeah, sort of trying to raise the visibility of what you are collecting based on the problems you've seen.
I can get the ball rolling with some experiences from a previous job when I was working at, I first came across this kind of monitoring at scale in a very different context, which was working in sort of high-end HPC with Cray. And, you know, you guys don't know you're born in terms of the richness of tooling and monitoring that we have available in public clouds. Because back in those days, I think that the really big systems, you know, these sort of most powerful supercomputers in the world, their telemetry was a large sort of max scale Postgres database, which could consume, say, 400,000 metrics a second or so. And everything was focused around providing just enough insight into what's going on. And so they were very much focused on choosing the signals. And because if you add more telemetry at that scale, it had this huge effect. And I think that sometimes maybe the tools that we have and the richness and the flexibility of the infrastructure might be in contention with scaling, so that if the more we scale, maybe the simpler the tools have to get, simply because we are working at such an enormous level of sort of richness of metrics, this real sort of haystack of data that's coming in from a cloud infrastructure. Is that true to say?
Yeah, I think so. I think one of the things so if you compare trying to monitor something on bare metal without OpenStack there, like OpenStack gives you those labels for things that you wouldn't otherwise get over time. So you actually have, you know, this machine has an identity in the system, be it a hypervisor or a bare metal node, that has a thing that you can track over time as an operator of that system. I guess I remember first coming into large-scale cloud and not actually. So previously, before going to Rackspace at Citrix, we were more looking at private clouds and where people had very specific needs and knew the applications running on the system. So I guess it was interesting in the larger scale public cloud where you didn't know your users in quite the same way. You knew some of them and got direct feedback from them, but you sort of got to see the different patterns that way. So maybe let's move to the third topic of kind of like interesting stories of finding and resuming bottlenecks in the system. So I think we've got some people giving some interesting commenting in there. So I guess we could try a section as well, which is, we said we're going to sort of share scaling horror stories.
Someone's put a well, not in the bottleneck section, but line 67, Rabbit MQ flatlining. That sounds like an interesting horror story. Who was it that?
Yeah, James, do you want to go through that?
Yeah, I put that one in. So Fortunately, this was not in a production-facing cloud, but was in some scale testing that I did a few years back with OpenStack. And RabbitMQ basically has a high water threshold for its memory consumption. And when it reaches that, it just stops accepting new connections until it drops below that threshold, and then it starts resuming new connections. So you've got this beautiful situation where you're scaling the number of instances on your cloud, and the port count's going up, and Neutron and Nova are all super happy. And you can see like tens of thousands of messages flying around as everything gets created and synchronized and all that good stuff's going on. And then it suddenly goes silent. You get this, if you're looking at the RabbitMQ management interface and the graphing that it provides, which is pretty good. It tells you a lot, especially when nothing's going on. You hit that threshold of memory consumption, and it just stops accepting new connections. And because of some of the RPC style semantics that we use RabbitMQ for in OpenStack, that means that things are waiting to get a response, and they're never going to get that. So you don't see anything happen till all those things start timing out again. So and nothing can happen at that point in time. So no mutation of the state of the cloud can occur. So kind of understanding how far you can push RabbitMQ in terms of message throughput and numbers of simultaneous connections to deal with RPC calls from the various parts of the system is quite a key metric. And there are a lot of things that drive that connectivity. And I think the biggest thing that I found was actually the number of ports and VMs you're running. The number of hypervisors is interesting, but in terms of the pure load of things that the cloud's trying to manage in virtually drives a lot of that connectivity. And in some of the older OpenStack releases, there were some well-intentioned concurrency parts to what Nova Compute was doing that had no upper limits. So if they would basically try and do as much in parallel as possible, and that could cause flooding of connections as well. So depending on what was happening on your cloud at any given point in time, you could really hit that hard limit, and then suddenly nothing's happening in your cloud, and it goes very, very quiet until everything starts timing out and you start getting the reconnection. But it does cause a bit of a reconnect storm after that point in time. So
thanks for sharing that, James. That's really interesting, and definitely brings back memories. So maybe for a production story, to make it more interesting, to make it interesting. So one of the things when I was working at Rackspace, I remember sharing at an operator session before, was around upgrades. And I don't want to re-go about upgrades, but I think it's interesting because it's about observability and Rabbit as well. It was, Rackspace is one of the early users of Cells v1. And I guess the way in which all these problems have been resolved is it actually fed back into the Cells v2 work to stop this happening again. But there used to be a synchronization piece from the top to the bottom. And this was a particular, we had some metrics that were looking at the length of the queues in Rabbit. And just as James said, we knew that if you got beyond this point, memory escapes me how many hundreds of thousands of messages it was, we knew that we'd be out of memory on Rabbit and everything would fall over and stop. So there was definitely a point where we would upgrade to the latest version. It would be doing a bit more work, and the queues would start growing faster than the consumers were able to consume. And depending on the pitch of that queue, we knew how long we had to fix the bug before things got really bad. But it's sort of, in terms of like how best to roll things out in production, I'd like to say this is kind of an example of where A/B testing in production kind of helped, because we had several regions across the globe. We'd always deploy to the smallest region first. So you'd kind of get to see if the message rates were particularly bad in the small region and get to be able to predict from the performance you saw in the small region how it would affect you by the time you got to the large region. So you could actually hot fix the smaller region, then move on to the large region. And this is all stuff that you actually, no matter how much you're simulating and staging, you couldn't quite get the same thing as you got in real production. That was always a thing we found. Don't know if anyone else has similar stories. Maybe has anyone got a database story to like be fair to Rabbit?
I would have a database story.
That sounds good. Go for it.
We have a Ceph object store cluster connected to our OpenStack and our Keystone. And we had an issue that we support S3 and we use the Keystone S3 to support this, or the S3 supporting Keystone to support this. The problem is we have UUID token and every S3 request creates a token in the Keystone database to validate the request. So at some point we had someone moving our archive, a big archive of small files into our object storage, and it generated thousands of requests per second. We prune our Keystone tokens after 8 hours from the database, but our database grew to 80 gigabytes during that time with millions of tokens and filled our whole disk, and our whole database crashed several times, and we had to prune it, recover, and try to fix it later. And our actual final solution was to ask the customer not to do that and hope that we can cache the tokens somehow.
So this is the leading question. Have you recently moved to Frenet tokens?
We have not yet moved to Frenet tokens, but this is on our agenda at some point.
Yeah, I remember that coming up very regularly in, before we had Frenet as an option. It's a great warning thing. I guess another thing is that, and we spoke about, I think there's some lines in the Etherpad about what is large scale. I guess James, you picked up on this a little bit. Like there's the size of your individual region. There's how many regions you have. Are you an edge site with millions of regions? And there's the rate of requests going through the system. So one of the things that you can also get on the DB side is the need to prune. So particularly Nova is good/bad at this, depending on how your opinion is. When you delete an instance, there's still a record in the database, and then you have to go and prune it. So over time, your database gets larger and larger. And certainly, I think this was at Rackspace with some of the smaller cells, there's actually a fixed size memory inside that VM. And there is a tipping point when suddenly your table scans and indexes become more expensive because the memory cache, you sort of trigger a different behavior in some of the queries. So certain queries get very slow, which is very similar to what I think you were saying about the UID system. When you get large tables, the indexes get large, and eventually you have problems with the index. Certainly there seemed to be a tipping point there. So this is on line 149 on the Etherpad. There was a comment from Dave H about Nova and RBD. Would you like to share that?
So this is actually two stories in one, but it's the same story. So originally we had the Nova services deployed on the Bare OS a long time ago now. And the default OSU limit for file handles was 1024. Then we scaled up the Ceph cluster underneath it, and anything that had a large number of volumes attached, and some of our users' workflows at that point relied on attaching and detaching a whole bunch of volumes, they suddenly couldn't talk to more than, I think, 9 volumes because it needed that many TCP connections to different OSDs in Ceph. So yeah, we fixed that one. A couple of years later, we ran into the same thing in a different disguise. This was after we had the service containerized. It turned out the container had been built with a 1024 limit at that point as well. So yeah, same problem, 2 different incarnations.
Do you say, when you see issues, do you check that more often now?
We set it to some insanely large number. So if we ever hit it again, then we've scaled our stuff a really long way. I honestly don't know how we could have seen this in testing, because our test Ceph cluster is very small, well under the 1024 limit that we would ever have seen.
Ties in with an interesting comment further up about a keenness to use Zool for testing configurations before they're deployed. And that sounds, I mean, that sounds like exactly the right sort of thing to do to avoid painful outages. But how do you do it to qualify a deployment at scale, where scale factors can find edge conditions far more effectively than a sort of a reasonable sized test cluster?
If anyone's done that, please do share. Or has steps in that direction. That would be really cool. I mean, going on the file limits thing, just to add another data point, I do remember hitting very similar issues with Elasticsearch, where it's one of those things that you just go, oh, just set it up, you know, simply. Eventually you find the production checklist that tells you all of the things you should have done. And it sort of suddenly it becomes more critical by accident when people start using it as a single source of truth, and then it becomes more disruptive. So I'm guessing, have people got strategies to find time to invest in observability to try and make progress? Have people found ways in which they can do that? Any good tips? I guess Stig brought up one earlier, which is the so if you use retrospective, then you can use a retrospective as a way in which you can drive through a change that makes you hurt less in the future.
I think that's the key, isn't it? Rather than just patching these things over and you know, fixing the exact issue that you hit, thinking a little bit more deeply about it and the potential for similar issues in future in a retrospective or other conversation, and then actually making the time to go back and fix those things is really important.
So we had another entry from Felix about Neutron L3 agents. Maybe you're just saying beware the file descriptors. I don't know if you wanted to say any more. So maybe if we go a bit further down the Etherpad, there's been a discussion about HA proxy, which is another great thing to look at the health of the system, like the rate of request and stuff.
I think it's been the best thing we added this year to our telemetry, simply because it provides you with a really nice visibility by endpoint and by return code on how your cloud is performing in a way which can be graphed over time. It's very nice high level view of what your users are seeing.
Has anyone got things they want to share about HA proxy?
Does anyone have any tips on how to take the huge amount of data that you would get from telemetry like that about every request and distill it down into something more useful, that, you know, a single or small number of metrics that can really give you a feel for how your system is performing and how healthy it is?
I can share a quick thing from Rackspace. We had what seemed like a relatively simple SLA, which I think we've spoken about quite a bit at previous events, where the SLA was to do with the number of 500 errors. So basically, if the API was returning 500 internal server errors, then the API was considered to be dead in some sense. So we failed to deliver your request. So we were, at that time, we were measuring, like, what's the percentage rate, you know, what's the number of 500s as a percentage over time. When it dipped over a certain amount, that sort of broke the SLA. So I don't know if people have developed other kind of summarizing metrics in that sense, or what they found that's actually helped drive, you know, understanding what the users of their service have been doing. if that helps spark ideas.
I just added a link to a presentation one of my colleagues gave to the large-scale SIG on what we did with programming or processing HA proxy to get histograms out. Might be interesting if you're following that.
So someone's made a note about the large-scale SIG working on Oslo metrics, which I have seen a bit about over the last few months, but I'd be interested to hear more about that. Was it Thierry or someone else?
Yes, it was me. So we've been working with folks from Line to get them to publish as open source the framework they are using to instrument the calls to RabbitMQ at the Oslo messaging level. So rather than have RabbitMQ's view on what it's receiving, try to get the OpenStack side view of what we're calling into RabbitMQ and how well that works, because we think that it will help us quantify or identify early the bottlenecks into RabbitMQ and then drive potential solutions in terms of sharding the types of calls in various RabbitMQ instances. And it is a good example of what the type of things we're trying to achieve at the large scale SIG, which is how do we push back the limits in terms of scaling once you reach a certain size in a single cluster. So what breaks first and how can we push back that? And it seems to be RabbitMQ is one of the first things that fail when we start adding nodes. So how do we instrument that? How do we detect that early? And there is an initial version of the code which landed in Oslo metrics library that I invite everyone to check because it's the proof of concept that is being used at Line for that specific purpose, but to make it useful for everyone, we need more engagement from other operators of large clusters so that we make the tool useful to them too.
Are there any examples of specific issues that have been found through this new instrumentation that couldn't have been found through the RabbitMQ metrics?
I think Masahito will be here in the next session and will be able to comment on that better than I do, based on their usage of the tool. But if you watch the presentation that the Line team gave in Shanghai at the OpenStack Summit in Shanghai, there's a presentation from the Line team on the type of problems that they detected with their RabbitMQ installation and how they mitigated most of those by using the tool's input in terms of how many types of calls are made and which ones are failing and where do you have contention, that type of information. I'm looking forward others to try that framework and tell us how it's useful to them. See if that's something we should generalize for more than just Oslo messaging, but potentially Oslo DB calls and other Oslo level instrumentation of the calls that we're emitting from the various OpenStack services.
So something that came up yesterday in the upgrade session, I guess, was general feedback on, I think it was Rabbit 3.7 versus 3.8? I think 3.8 is the newer one that added, so among other things, that added the Prometheus collector, And so we spoke about HA proxy, the latest version having a native Prometheus collector. The same thing happened on the Rabbit side. I don't know if anyone's got experience of using that version and if that helped with visibility into the system.
I think 3.8 is still fairly new, isn't it? I can't remember exactly when it came out, so it might not have that much deployment or production exposure yet. So, but
It's
that sounds
newish,
like a
yeah.
really cool feature. So,
Yeah, I was hoping the folks that were saying about it yesterday were on. It's true. It's not. I think Erlang dependencies mean it's a little hard to upgrade sometimes in OS packages.
yeah, I think from an Ubuntu perspective, we only put it into Focal and didn't backport it to Bionic because of the Erlang dependency issues. So,
oh,
yeah,
okay. Well,
So I'd be quite interested to hear from anyone who has experience of trying to benchmark and profile things at scale without the system available of the scale that you're aiming for. How do you get to the next level without actually having that system available? There are various different techniques you can use to do this. I've tried different things in the past. I'm currently having fun with Ansible doing that kind of thing. Obviously, there are some things you only really hit when you actually do the real thing that you're trying to do, but there are also often lots of different bottlenecks and avenues that you can explore without having that hardware available. And perhaps I can kick things off just talking about Ansible, which is the language I seem to spend most of my life in these days, which has its own unique challenges. It's quite an interesting tool in that it claims to scale to really quite huge numbers of hosts. But if you try to write it without thinking about it or without actually testing it at that scale, then it's pretty likely that it won't. There are various things that are bottlenecks, particularly on the Ansible controller side, i.e. the host where you run Ansible. Things like template generation, iterating through groups and things. These all happen on the local node, and you can throw more hardware at that, but you get to a point and you will hit a limit. So I've been doing things with Kobe and Collar Ansible recently in a reasonable size environment and looking at the issues that we hit there first. And one in particular is gathering facts. So when you get to a certain scale and you run naively with just gathering facts at the beginning of every play, then that can really take up quite a lot of time. So the tool that you typically reach for at that point is something called smart gathering and fact caching. So Ansible can gather facts from a remote system and then cache them locally, and then next time it will just use that cache, and that works very well. But there are a few areas where you can get tripped up there. So the context in which you execute Ansible might change and actually can influence the facts that get gathered. So if you depend on facts that can change over time, then you're going to run into issues there. So another particularly bad one is dynamic including of roles and tasks. So when you're talking about tens of hosts, then including a role or task file is it's pretty minimal overhead, but by the time you get to hundreds, it's taking tens of seconds to just include that file. So switching to a static import where possible can shave quite a lot of time off. And then I guess the last obvious thing to consider is skipping. So again, at small scale, skipping a task is almost instant, but when you have a large number of hosts, there is an overhead in just executing a task, whether it actually runs or not. So trying to reduce the number of skip tasks that you run is a good avenue to explore. I'm sure others have experience with scaling Ansible as well. Be interested to hear about it.
So maybe as an aside, when I was looking at deployment tools in the past, one of the ways that we try to think about the problem was that there's usually at least some part of the work that you want to do within at least an at-risk window where people know something's going to happen. So you try really hard to reduce the time in the at-risk window by doing pre-work that in theory is less risky. And to reshare an example that I remember happening at Rackspace in particular, was when trying to push out the new version of the code. At that particular time, we were using, it wasn't using containers, but using tarballs of VMs. So before the risk window, the team tried to push out the tarballs of the VMs to all of the compute nodes. Now it turns out there was a firewall between where the tarball lived and the compute nodes, which is where all the control plane traffic for the cloud went through. And actually in pulling that tarball through the firewall, you basically took out the bandwidth for all of the control plane traffic. So the computes can no longer talk to RabbitMQ and such like. So there's definitely risk in that split. I don't know if you all have other stories on how you think about these optimization problems for operational activities at large scale. Again, this is one of those things that when you try it in staging, it doesn't hurt you in quite the same way.
So if you have, Prakash here, if you have in Rackspace multiple zones, and if you are running some large applications across the zones, does the load balancer go through the internal network, or does it go through external? How does it happen, the balancing?
So I'm no longer at Rackspace. I don't want to speak to them what they do today. This is just resharing what we did in the past. In that particular case, it was just that you wanted to track traffic going through to the hypervisors. And there's a common pattern. You can put a firewall there. So it wasn't really a load balancer as such. It's just that there's when you firewall off part of your infrastructure, if you're not careful, that firewall can be a bottleneck. I've seen it in similar. It's the same if you're trying to actually, if you're using firewalls in any of that kind of way, right, you get the same problem. It's just that if you're not 100% sure of where your topology, it can hurt you. That makes sense. As in, you're not sure where the bottleneck is until you hit it sometimes, if you don't have full visibility into everything.
That's right.
So I think the official end of the session is in 10 minutes. I don't know whether we'll stick to that. I think we probably started a little late, but just thinking in terms of covering the topics, we've got a few different ones to cover. Sean, what do you think?
Yeah, I was thinking of moving towards the ideas on sharing, if that makes sense. So I guess this has come up quite a bit already. Like Thierry gave a great example of someone finding something really interesting and sharing that with the community. I'm just wondering if there's ways we can think about, what are particular efforts that people want to share more on. So offering up an example, or sort of two examples that have come up a few times at various, I think it was a security SIG OpenDev event previously, at one of the security SIGs at the PTG, I think. Wazar came up as an interesting sort of security and auditing system, as a really interesting way of people, an example of people sharing their list of things that you should check to monitor the security of your system. So in terms of like as a group effort, having that sort of group think and sharing that through a tool, Wazar seems a great example of that. I guess I'm a bit biased, but I kind of want to say sort of like the deployment tools in OpenStack are doing similar things, in the sense that Collar Ansible, out the box, can give you sets of monitoring and sets of, it gives you the ELK rules and FluentD rules to start collecting the logs centrally and start collecting that, and you get an awful lot of information. So certainly with, we certainly saw in one upgrade going from Rocky to Stein, there was a huge difference in improving the collection of that centralized logging. There's just one example. But I guess, I'm wondering how people are thinking about this. Yeah.
I think generally monitoring has always been a bit hobbled because there's so much divergence or diversity in what people use, and it can make it quite difficult to find common infrastructure. But I think what you've just called out there is a couple of examples where it has worked and it's demonstrated the advantage of sharing these things. So it's pretty clear that it's something that actually would be a good idea to find ways to do more of, I think, for everyone's benefit.
I don't know if people have got the OS Ops repo had a certain amount of activity about, like, this is an interesting script for visibility or for doing X. I don't know if people have. It's not had an, I guess there's been less contributions recently on that, but that kind of thing. I guess there's one line in here that has a whole load of +1s, which is it feels bespoke to my needs, and I think I'm wondering how, like, if someone feels like their system is bespoke to their needs, I don't know if they want to share why they think that, to see if that is true. Just a lot of the time it feels like it's just scratching my itch, it's bespoke to my needs, and then when you share that in sessions like this, you suddenly just, actually there's loads of people that would like to see that. Oh, that'd be great, Dave.
So I put it near the top of the Etherpad. We have what I described as a hacky script. It looks around the free capacity on the hypervisors, compares it to the various flavor sizes, and then records how many of each would fit in the available capacity right now. So then you can graph that later on with Grafana. You can look at it for trending. And that's useful to us for, well, it's very cheap and cheerful in terms of capacity planning. But also the users can see, is OpenStack busy right now? Is it full of other people's stuff? Or have I got a chance to stand up my monster cluster? Is that something that other people do? Is it something that other people might find useful? I have no idea, but it scratched an itch, as you say.
I'd say yes, because I think actually one of my first tasks that Stig asked me to do was to do something for bare metal in a similar kind of way. So I was looking at the bare metal host and seeing which ones are available, because we had exactly that question from the users of that cloud. Can I launch a big instance today? Is there space?
Yeah, that's exactly the sort of question we kept being asked.
Yeah, no, I think that's a great thing. So, yeah, I don't know what people think about in terms of visibility, in terms of helping, I guess. We should maybe all be more reactive at sending out those ideas.
In terms of that problem of how do I test these things at scale, which is a difficult one to answer. There is a contribution, I think, that we can talk about, which relates to a long-standing partner of ours at Verne Global in Iceland, and they've made available a system of 160 blades 160 compute nodes, and we have a project with them which we are hoping to take shape over the summer to make that available to community projects to do testing at scale on physical real hardware. And the idea is that Verne Global are active supporters of open infrastructure and this community, and they want to be able to make use of this nearly new hardware. Well, it's a few years old. But for us, we're quite interested in creating a machine which exemplifies a lot of the different ways that infrastructure is used within a OpenStack cloud. So the idea is that we make it available for workloads, and we try and support the different ways that workloads would contend for a fixed space resource by using reservations and preemptible instances and things. But that's going to be coming online as a physical contribution rather than a contribution of code in the course of the summer. And I'm hoping we'll make it available possibly through a forum like the Large Scale SIG or other things to enable scale testing of open infrastructure projects. Doesn't even have a name yet, so watch this space.
Thanks for sharing that, Stig. There's some good discussion on the Etherpad in pink, I think, saying on line 249. I don't know if someone wants to talk about that a bit more. So the OS ops there was a discussion on the mailing list. I don't know if someone could.
Yeah, that was this is Eric. Yeah, hi,
oh,
this
thanks,
is Eric. Hi, how you doing? Hi, yeah, that was me. Yeah, we set that up back many years ago. I don't know, Tom Beifeld was still around, kind of thing. And there was a little working group that was kind of organizing it originally, and we changed the format of it a couple of times. But that group just kind of, was never really a formal thing. There's a wiki for it out there if you could find it. It still has Tom's name on it. He's the last one that edited the page. But we had a conversation on the mailing list. I think Mohammed started it up about trying to create some sort of organization to maintain that thing and make it a little more useful to people. But it just kind of fell off into the ether, and most people don't even know about it anymore. So I think some sort of organization around it would be good if, anyone's got a few minutes to volunteer, about like a once a month meeting or something like that, just to kind of come up with a plan for making it more useful to people. But in terms of the whole bespoke to me thing, it was kind of a place where you could put that sort of stuff. Even if you thought it was, just for you, you'd usually find out that it was actually something that other people needed too. Like I can think of one example where we had a conversation about Neutron not allowing discontiguous external networks back when it didn't offer that. And somebody had a little Python script that called ragged external networks that would go and create you a discontiguous IP allocation range and put it in through the API. And that person thought that wasn't, that was just something that they needed, and it came out in discussion at an ops meetup that, hey, I have this problem too. So even if you think it's just your problem, it's probably not just your problem. So definitely think about contributing to things there, even if even if it's something you think is just for you, stick it up there anyway, because it's not going to hurt anything. There's a generic repo in there that's not curated. It's just, if you think it might be useful, put it in there. It's not gated. There's nothing special you need to do.
Thank you for sharing that, Eric. That's a good idea. So looping back to Dave, do you think that would be a good way to share your script?
Yeah, I think that's a really good idea. We might need a tiny bit of polishing before we let it out the door, but yeah.
I like the idea that it doesn't have to meet sort of a peer review standard, because that would probably discourage a lot of people as well.
Eric might say more about this. They had a nice structure where you have a graduation process, so you can share it. So if when the second person wants to use it, they can tidy it up and maybe promote it. But it seems like a good way of getting discoverability.
Yeah,
I agree.
Yeah,
strongly.
I think Yeah, I think so, and it was meant to be you know, a low burden kind of thing, so that people didn't have to, you know, spend a lot of time. You know, there's no particular code standards applied to it. Nobody's going to -1 you because you forgot a comma or something in your comments, or you know, there's no particular reviewing going on. Although it would be nice to have, you know, a group that periodically went through there and made sure there wasn't, you know, drift that, you know, just didn't belong there. But you know, it shouldn't take too much work. It's kind of taking care of itself. It is tied to the OpenStack operators IRC channel. So if somebody makes a commit, you'll see it pop up there. And every now and then you'll still see one go by.
Cool.
So John,
that's probably a good time to stop. Yeah, I was gonna say, Mark, I see your face appear.
No, this is amazing. I was really hesitant to jump in. This is a great thing to end on, though. I think there's some solid actions to follow up on. So great session. We're just going to take maybe like a 1-minute break so folks can have a little breather, and then we're going to jump into our next session.
It's a 1-minute break. It used to be 5 minutes. Oh wait,
well,
it is 1 minute.
we ran just slightly long, but it was a great session. So I think that, yeah, if we can just, I think Aaron might be putting up our break slide, and then we'll have a short time, and then we'll jump into Beth. I think Ashley will bring us back here in just a minute. Or I can just sing.
There it goes. It's okay.
Okay, so yes, the break is almost over, but take your break and we'll be right back.
All right, let me put up the link to the Etherpad for the next one.
All right, I think it is a good time to go ahead and get started again. Hope everybody enjoyed their 2-minute break.
Hey, I did manage to get up and stretch.
That's important. Yes, I hope everybody got a chance to stretch. All right, well, Beth, I will go ahead and turn it over to you. So thank you so much to Beth from Verizon for moderating high availability networking solutions.
So thank you, everybody. So I encourage everybody, I put the link in the chat, but I think it's available in other places as well. So I encourage everybody to jump on and put their names in. So this session, and Chris is floating around here someplace as well. Oh, there you are, Chris. So this is co-hosted by Chris and myself. So this session is focused on high availability networking solutions. And I think one of the first questions I have to ask is, what does high availability mean from a network perspective? So you'll notice I have some questions to get started. And I think the first question is, what does high availability mean? You know, where do you do it in your infrastructure? And I'll share what it means to me a little bit. So high availability in my world, particularly around networking, means failover to multiple other instances. So in the case of a firewall, we typically have, you know, a failover, regional, you know, multi-regional failover. So that if, so literally if the data center goes down, not that that normally happens, but it could, you know, backhoes do pull cables, then it will fail over to another data center. So extreme high availability. So that's, I want to open it up to others.
Thanks, Beth. This is Chris.
Yeah.
Just wanted to chime in. Been lurking here quietly, but high availability is interesting. I don't think about high availability in the data center. Actually, I think the data center becomes it becomes a little bit opaque as to how high availability is built. When we used to build high availability applications, it was down to the point when we knew we were running on batteries, for instance, was how we were programming things to make sure that there was no way the application could fail. And the cloud kind of removed that and changed the paradigm of what is high availability anymore. And it's been abstracted away, I think, to some extent. And it's good to have a conversation like this, because what is below the abstraction and what do I need to consider when I'm planning a high availability solution changes, and it continues to change. Now, when you throw Kubernetes on top of OpenStack, then the abstractions just become, you know, even more so. And planning and defining high availability becomes even more of a challenge. As you say, backhoes exist, cables get broken, data centers go offline. So thinking that ingress is going to solve my problems is maybe dreaming a little too much on what you can get from the infrastructure and platform layer. But I think it'd be good to hear from others.
Sure, Chris. I'll bite.
Yeah, go.
So this is Arkady Koneski from Dell. So we have been, when we developed our first OpenStack solution, God knows, 7 years ago. So we kind of looked at the high availability in layers. So what I mean? Well, first is that from the hardware point of view, you have multiple redundant components. So from the networking point of view means that you have, you know, dual data switches, each of the, you know, servers connected to both of them. From the if you look at every server have multiple NICs and multiple ports on them, such that we do the bonding across the 2 ports on 2 different NICs, and they are connected to different switches. So that means that failure of any single components will not take you down. It
But
might
that's
degrade your performance.
extremely expensive and very wasteful.
Agreed. But it's so you're bringing up the point is when you are looking at what I would call the high availability or resilience in general. What is the level of the fault tolerance you are interested in handling? And based upon that, you kind of build your solution based upon that. Yeah. If you're and so this is kind of from the hardware point of view. Go level up, you have each of the components. For example, multiple, the triple controllers, which is becomes standard in the OpenStack. You have multiple, compute nodes, multiple storage nodes, multiple controllers, such that any failure of any single thing does not take you down. And then there is a resiliency within each individual node, which is monitoring each of the services running of the platform services. And when any of those are going down, it will restart them, or at least try to restart them in a different level, depending on what kind of failure it happens. Again, this is extreme. I don't disagree with you, but again, it goes down to when you look at the high availability, or to be more fair, resiliency, you go in layers and you align to what is the model of the failure you're trying to handle.
So let me, okay, somebody else.
So I'm sorry, this is Eric. I just wanted to pipe in on that, just in terms of it being an expensive option versus single connected things. We single connected things for a long time, and still have it that way in a lot of places, but not doing it in a sense is more expensive because it makes upgrading switch infrastructure significantly more difficult, causes outages when you have to do it. Single switch croaking causes issues, with things. People, are running replicated things on our cloud, and so when stuff like that happens, a node loses connectivity, you immediately split brain their database, and they tend to get upset about it. And we also run a lot more lights out data centers where we don't have anybody present there except for some guy that we can call to go out and move cables. So having that resiliency in the network is really kind of critical for us. So we started running dual MLAG trunks on every host, and it's been worth doing, I would say.
So let me add some comments. So this was a few years ago. I worked on an OpenStack implementation that was it ended up not going anywhere, but it was supposed to be a really large one. And I had a long argument with one of the architects about how many switches should we put at the top of rack, and they wanted to put dual top of rack switches. And my argument was that if you treated the node, the rack, as the failure node, you would save yourself, and I did some back of the envelope calculations, that it would save them about $6 million in not having to do dual top of rack switches. That was, I think, something that they had a hard time understanding. And I think they were very nervous about taking the rack as a failure node. So just some comments on that.
I think that's okay in a manned data center, for instance, but you've got to be able to accommodate the loss of a rack and then recover that rack in a timely enough fashion. A remote
in a large
CO
data
solution.
center, that's okay. It's not, if it goes down for 2 days, who cares? And then somebody can show up and, do whatever it needs to be done to fix it.
Yeah. So really it's about adjusting to scale. It's cost versus scale, right? How much can you afford to lose on a failure as far as capacity is concerned in those kinds of equations?
And Sigs adds his comment. Rack level failure. And I think that works best in the large scale data centers. I don't can't say for sure, but I'm pretty darn sure Amazon probably assumes rack level failures. But where it gets trickier, I think, is at the edge, where you don't have, you don't have as much resources. So getting back to network, at the edge, you're relying on multiple network paths. Can you assume you have multiple network paths to save yourself?
Exactly. Where on the loop are you, or where on the ring are you? It's and that's interesting. I mean, if we roll the clock back to before we were trying to virtualize things, and you built your ring and you had a bunch of equipment there, and everything was in dual pairs, and as you then start to virtualize things, and we start to see virtualization of optic switches and optics into the data center. These sorts of things can even change the paradigm of how we handle high availability in the physical layer, which I think is actually super interesting, and even though it's been around for a few years, quite early in its life cycle. But it's hard to do anything HA without at least physical redundancy, and then how you apply software redundancies and the capability to take advantage of that on top is I think a moving target in today's games, at least on the research side. I don't know if anyone's looking into those sorts of things where you're bringing dark fiber into your data center and then essentially handling it from there.
So just 2 comments. We're going to be starting a poll, Aaron, on pain points around large deployments. So feel free to fill it in as we go. So Aaron, that's your cue to start the poll. So I'd like to circle back to the network itself. So obviously I'm speaking from a telco perspective, and redundancy, network redundancy is something that, I'm very comfortable with. And, when we talk to our customers about network redundancy in high availability, what I find is we're talking about something that is beyond what a typical customer understands. So, for example, in good data centers, high availability of the network includes multiple providers and multiple entry points into that data center. And that's just telco thinking that high availability means 6 nines. However, most enterprises don't really think of it that way. And how can that be how can software-defined networking and large-scale deployments address that very expensive solution? Is there a way to address it? And I am opening it up to the community.
Hi, it's John G here. I just wanted to, Dave was also mentioning we're having a little miniature Ethernet chat, Etherpad chat rather, Freudian slip. And so we were talking about the problem with applications, because often you don't really get, depending on the cloud, you sometimes don't get to influence the applications being run on it. In that particular case, how do you make sure that the system, like for example, is it cheaper to actually pay for those extra switches than try and restrict the applications running on your cloud? But I'd be interested to see if there's SDN fixes for that too. was line 48, 49.
Yep. So, I mean, how many people are using, you know, within the data center? What, so moving on to, so some of the other questions are you in fact concerned with network failures in your environment? You know, is that even a problem? You know, do you think that, you know, having diverse pipes from AT&T and Verizon into your data center, is that sufficient?
Yeah, this is Eric. I mean, we've always had diverse pipes into all of our data centers, and you know, run BGP. Honestly, for you know, from a bandwidth perspective and a, you know, cost of carrying something like that, it's insignificant enough relative to the cost of a complete outage that it's always been worth doing. You know, and it kind of circles back to the same thing about using MLAG. Honestly, now I think about it, really, we're not using any more switch ports, or just slightly more switch ports than we used to in a single connected environment. It's just that we have an extra switch in there now, so we're running our bonds to multiple switches instead of single switches. So you know, it's just an expense in terms of the extra switch in the rack, but
which isn't that expensive.
Right. Yeah, nowadays it's just not that, and we're running cumulus switches that are, you know, like a couple of grand, so it's not really that big a deal, relatively speaking. So it's definitely, you know, become more tenable to do it, and it's as the cost has come down, and you know, again, I guess it just depends on your workload, right? You know, if I was just running all Ceph clusters and I, you know, set my rack level failure domain, I'd probably be okay with that. But for, you know, for OpenStack, I don't know always what workloads are running on what computes and where, and you know, things could be, you know, a row away for, you know, for some people's applications, and you know, they may not like to have, you know, have long interruptions like that and then just magically come back. And I can't control everybody's applications, and I can't worry about, you know, individuals as much. So I need to just kind of build for the worst case, and you know, with the best, you know, with what funds that I have available. And you know, so we try and take at least dual connected like that, and you know, dual provider ISP wise, and you know, multipath routing in the data center, so that we can kind of create that resiliency, but you know, not go too nuts with it.
So actually, Eric, you bring up a good point, which is that I think that we're talking about sort of two different types of workloads. So you're talking about a workload where you don't have any control over the workload. It's, you know, random, right? It's sort of the public cloud model, essentially. You know.
Yeah, I mean, we have a private cloud, but we have multiple customers within it, so it kind of behaves like a public cloud in a way. I'm not provisioning everybody's things, and it's not all one application. It's lots of different applications running around, and like I said, I know there's a lot of like replicated data things in there, like Cassandras and Polaras and various things that get unhappy when they get connected from their friends for, you know, long periods of time and then just magically come back. And I'm not great.
Right, but you have to build in a way to support whatever random workload they put in, because you don't have any control over them.
Exactly. Yeah.
But you know, in a telco world, we have a lot more control over the workloads. In fact, the data center, I mean, our data centers are tuned to support the workloads because we know what the workloads are. And we do typically, particularly in the networking ones, typically do know what the workloads are. So they're in support of our networking infrastructure.
I mean, ideally, all the HA should happen at the application level, right? You should not be reliant upon your underlying infrastructure as a developer, but that's, you know, unicorns and stuff. So
It's not really possible to say that HA happens at the application level if there is only one way for that application to connect, or one place where that application's information is stored. I mean, you know,
Yes,
there is a shared burden, and I think that's the challenge of an application developer is you have to know what your target is in order to know that you've achieved HA. And as Beth sort of alluded to, their data centers are tuned in a certain way so that the people providing that software know what they're delivering into, and they can achieve the number of nines that Beth needs in her network. And I think that's the challenge in cloud. I mean, at the end of the day,
I think you nailed it. I think the question of the SLA, and if you expect that you can deliver the SLA simply looking at how you developed your application, I think it's somewhat missing the mark, because you have to have SLA of the, call it platform or the cloud, and then there is SLA of the application itself, or design of them, and you cannot deliver the end customer SLA without looking at the full picture.
Right. Well, and when people use public clouds, there's an assumption, implicit assumption, which is not in fact true, that public cloud has a high SLA, that it's not going to go away. But that's not if you read the SLAs of many of the public clouds, they're pretty much not there.
exactly, our cloud won't fail. I mean, we don't know what happens to your application, but the cloud's still going to be here. Yeah, that's not helpful.
Right, it's totally not helpful. So I just encourage everybody to take the poll. We have about 50%, a little over 50% have voted, so we encourage you to do it. Let's get there. Let's get to 90%. So moving on. I had a question about diverse network, and somebody put in diverse routes versus diverse manufacturers. So that again gets back to hardware. So can we have a diverse software network? Is that even a thing?
Maybe rephrase the question.
Yeah. Well, maybe the question is, what is a diverse network? What does that mean to you? And is it something desirable? I mean, from a telco perspective, diverse network is desirable. And as I mentioned earlier, diverse network to us means we buy some circuits from another telco, or we peer with another telco. That's what it means. That's what diverse networking means to us. That does not necessarily mean that to other people. Maybe we should just skip that question because it was just kind of.
Sorry, and this is Eric. I do have one thing to throw in there. I mean, the diverse manufacturers thing stresses me out. I do have some diverse hardware in terms of switching infrastructure, just because we run Cumulus, so we have a couple of different models of switches in there, a couple of different manufacturers, just depending on what we were able to source. But from an administrative perspective, they all look the same. So it's not too much of a big deal. We try to keep it to a minimum to be able to have sparing and stuff like that around. So I just try to avoid the diverse manufacturer part of it whenever I can. So that's generally not been part of my diversity strategy. But the rest
well,
of it is
let me ask another question about that, because if in software-defined networking, theoretically, you've disaggregated the hardware, and so therefore the diverse manufacturing shouldn't theoretically not matter.
Well, I run both parts, so I guess it kind of matters in that way. I'm running the SDN, but I'm also running the underlying network, so I kind of plan for both, I guess. But yeah, it shouldn't, from a cloud perspective, it shouldn't matter. You shouldn't care what's underneath, I guess.
That's supposedly the whole purpose of cloud, right?
I think as Eric was alluding to, SDN solves part of the problem, but what you want to avoid is diversity of operations, and manufacturers generally don't align on how things are operated.
Yes.
You know, you can get a common open flow northbound and everything else is different. It's not very helpful in the big picture.
Right. Well, and it makes HA that much harder. And we have a comment from Sia, which I'm not quite, could you explain in the chat? I wasn't quite following what you were referring to in this case. They might not be on voice. So the question is, in context of OpenStack, at the end of the day, the i3 agent is
L3.
Oh, sorry.
Layer 3 agent.
Oh, layer 3 agent. Okay. Oh, that makes much more sense than the question.
But it is a single point of failure, and
yes,
it needs to be engineered away or resolved. Yeah. Actually, don't know. Actually, it's a very good question. Is anyone, the last session was really about the large scale deployments. Following on from that, is anyone in a large scale deployment using the L3 agent?
As far as I know, we're not.
Yeah, I'm not sure how much it's used in the telco environment. I'm not aware of any deployments that are.
My deployment doesn't count as large scale so much, but we do use it. We use L3HA, and it works fine. Got like three networker nodes, and it's been sufficient to handle our needs. But I know some larger scale folks that I talk to mostly either are running provider networks or they're doing things like Calico or other things like that. So yeah, there's not a lot of. Most of the really big deployments are not running L3 agent that I'm aware of.
Yeah, I wanted to mirror what you said, Eric. This is John here. Yeah, we've certainly seen quite a lot of L3, but again, like a sort of delicate use of the provider networks for traffic that actually you don't want to go through the L3. So so an example from the scientific world is lots of like for the parallel file system, you don't want that going through an L3 agent. You kind of need the lower latency. So provider networks have been used there. I guess the question to the telcos, if you're not using L3, do you just have a single flat provider network generally?
I've never known a telco to have a single flat provider.
Yeah.
No, but I am wondering what your alternative is.
But I think, yeah, that's quite strongly leveraged in the telco world is the provider network. But yeah. I also know there's from an Ericsson perspective, we have a number of people we work with, and almost equally as many ways of solving networking. I mean, it really depends on the customer's networking or the operator's networking philosophy as to how that then sort of evolves into the data center and what tools you need to resolve for that. I don't think there's one button you can press and say solved. It's a complex space with a rich history and set of opinions. Sorry, go.
I guess a lot of people that are running really large deployments too. Some of them are running commercial SDNs, Nuage or NSXT or something like that. That really distributes that stuff out so that that obviates the need for L3 agent as well. But running L3 agent in a kind of medium-sized environment is perfectly fine, and running L3HA is great. DVR, I agree, has that problem where it's per compute node, but if the compute node heads and the L3 agent on it being so much of an issue. But in the terms of L3HA, it works, works like it's supposed to, because it's simple, stupid, keep alive D inside, and that just works. So
I suppose the follow-up comment is turning on L3HA with DVR, I think, is still marked as experimental.
Yeah, I've never touched DVR. Just I don't need. It seems like it almost feels like too much scatter for me, and takes up a lot of IPs. So.
Yeah.
I don't know much about
Hey
it.
guys.
Oh, excellent. Thank you.
Oh, I'm sorry for my problems. Okay. Actually, my question was that I think it was Eric that mentioned that the DVR consumes lots of IPs actually, and that's a lot problematic for us. In SDN context, I tried Open Daylight and Onus controller. In high traffic rates, they're not actually work properly. And I like to hear about your experience in Verizon and AT&T about SDN controllers and how you manage high throughput traffic.
Oh yeah. Yeah, we have, I actually don't know the details of how we're doing it, but I do know we do support high throughput traffic because we have multiple 10 gigabit switches going into it and support them with no trouble, but I don't know the details of how we're doing it.
Oh, I think you mentioned that you are using the provider networks.
Yeah.
And that means that you don't have any integration between the Neutron and SDN controller?
I actually don't know because I don't know the details of how that. I know more about the overlay than I know about the underlay.
Oh, okay.
So
But I think that's a common model.
James is yeah. So keep going.
Yeah, I was just going to say, I think it's a common model that your SDN solves for the networking side, and then what's happening inside the cloud is the responsibility of Neutron. And generally, no, not generally, but I have seen quite a lot that there is a network management and operational support system that coordinates, and the two are not coupled in any way. And it's just a separation of domain and separation of responsibilities, and that is a pretty common model, I would say.
Yeah, that makes sense.
So I don't know if James is on, but he can answer more about what we're doing in the underlay. So I would like to move on a little. We have about 15 minutes left, and want to move down to some of the other questions we have. I think we've covered how important is networking HA in the data center. So I'd like to talk a little bit more about it in the edge environment, because I think that's a very different environment. And I think that how you do HA in the edge has to be a different way. I know our experience is that our customers are asking for HA at the edge. We have those edge boxes that support networking applications. And when we originally rolled it out, we did not have an HA strategy. And that was probably one of the first things that our customers were asking about. Well, can we get HA at the edge? And so we ended up doing a number of things to make it work. We have application HA. We take advantage of many networking applications and firewalls, and as a perfect example, have have HA built into their DNA, so to speak. And they do full stateful HA. And they but we also do it with dual boxes. So the idea is the HA, you know, we assume a box failure is the like in the data center where it's a rack failure, we assume a box failure. We did make a deliberate choice not to put dual images on a single box. We felt that was kind of silly and expensive, given that the box it's not a rack of stuff, it's just a box. So we made the decision that the HA, if the customer wants HA, it's spread over 2 boxes, and then it fails between the 2. So, any other thoughts about, you know, how to address edge is it possible to do HA in a mesh form, or, you know, some other way that isn't specific at the local level? And please note that poll is ending. So Erin, should I end it? Okay, she just did it.
Got you.
Thank you. Thank you, everybody. Looks like upgrades, biggest pain. But I think we heard that yesterday too. So that is clearly within the, and it's interesting, HA did not get high results. I'm curious as to why that is. But clearly there's a lot of people who are interested in HA because they're all on this call. So, thank you for the results. So any other thoughts about you know, HA at the edge? Should it be treated differently? Should those edge nodes be treated as cattle that can disappear at any time and presumably come back? What about HA networking, you know, out at the edge? So typically our response is we require a out-of-band access for those boxes. So that if the box fails, you know, we can still get into it and kick it. To you know, if it gets into some race state or something.
Prakash here. Interesting. You talked about the pet cattle and the pet here, but at the same time, if we can have a radio peering at the edge over there, that could be a way to preserve the state. Of course, we do want stateless, but that's going to be a challenge all the time, especially with the state transition being managed through Kubernetes. We still need some kind of a what do you call it, the edge, kind of a persistent volume to maintain and transfer the state, like we do in the radios, like prepare and then execute and make sure that handover happens. Something very similar, we need something on the edge, I believe. Now, I don't know, it's a out of box thinking, but that's a possibility, because we never hear about radio peering. We only talk about fixed line peering in the ISP's world or in the large scale at the multiple edges. So I don't know what you think on Verizon side of it. How does it work? It's a pet cattle. How do you handle that?
Pets. Yeah, that's a good question. And that brings up, you know, the LTE deployments, the radios. The radios have to be considered cattle. You know, if a site goes down, it has to be, the signal has to be picked up by its peers. I can't imagine it's done any other way.
That's right. That comes down to radio planning and how you make sure you have coverage and yeah, you don't try and solve resiliency with a bunch of optical cables going to one antenna. It's just not helpful.
No.
But yeah, to be honest, when you were asking the question, Beth, my brain was running, okay, on-prem. I mean, if I have an on-prem solution, let's say it's something residential, then generally I'm plugging into a cable box, and when that goes down, I want to make sure I have some sort of LTE 5G thing picking that up to make sure that it still kind of works. Maybe I can't do my HD streaming at that point, but I don't lose the functionality. If you move up, if you move a little further along, and then you come to that peering point, you've got the curbside box. Well, the curbside box, unfortunately, it's very hard to get multiple connections into there as well, and there you have what is essentially a single point of failure for a very small number of people. You move up a little bit further to some sort of a peering point, and then you're generally on an optical ring or something equivalent, and there you will have multiple devices and multiple cables coming in, and that's where you'll start to have site resiliency. And we build and we architect for these things, right? So it's really a question of what is Verizon's philosophy when it comes to how you want to address some of these questions. What are the best practices and how do you want to apply them? And then you sort of go from there and make a number of decisions around how to establish resiliency in the network. And what changes then is what software you deploy at different places to support the needs that you have based on those decisions that you've made. And it's really hard to, without a picture in front of us to say this is how it's going to look, to talk about what softwares we need here or there or elsewhere. And I think that's one of the challenges we have in especially when it comes to network HA. So many options, so many choices. And they come down to, am I on an island? Am I in a city? Am I in a remote place? That then you have different decision functions driving how you build an architecture, which is eventually results in what is the software I'm deploying there changes accordingly.
Well, and also where in the network and how the network is architected is going to affect where you put the resiliency.
So, Chris and Beth, I am reminded of M2M at the meter reading, where we used to have a SIM which will be a backup for over the air to be able to implement many of the use cases. Something similar. So you always have a SIM over the air as a backup for fixed line connectivity. In M2M.
Yeah, it's a good resiliency system.
Right.
Yeah.
Yep, that does. That makes sense. Well, I think we're down to the last 5 minutes, right? It goes till 1400. So, so I know we only managed to get about halfway through the questions. I guess that's good. So I bring up what OpenStack components are important to networking HA. Obviously the tools in OpenStack are limited to Neutron and Nova, but that's just the OpenStack components, and do they support HA? How well do they support HA? And can we consider adding some new features to make them better? And we talked about L3 already. So again, I open it up.
I was hoping someone that knew something would speak here, but I actually have a similar question. I know that OpenStack, we have a bunch of good tools in place for how we're running OpenStack workloads, how we're spinning up VMs and so on and so forth. And I know we have emerging and developing tools for how we best support something like a Kubernetes or a platform as a service layer on OpenStack, where all of a sudden the workload pieces are sort of removed, but the infrastructure itself still needs to provide those mechanisms. And I have a lack of visibility, I think, in how well we are addressing that, and how our tools that we've developed, which are great tools, are emerging and evolving to support where you don't have as much visibility into the application need. It's generally abstracted through some platform layer. It would be great if someone had some insight into that specifically. I'd be very interested to hear.
So, Chris, as far as I know, Heat has got the capability if you have networking, but that's provided somebody can debug, which is very, very hard to use. And Heat Stack is the real difficult portion of it to even trace anything there. It's very complex. So I have not heard of any tool whereby we can do a network HA. I have not really.
Yeah. I always find that we end up doing it at the application level or at the box level. We're not doing it at the OpenStack level, particularly.
So just wanted to bring up anti-affinity rules. I don't know if people make use of those heavily. There's definitely scheduling issues at scale with anti-affinity rules, so they get turned off. But
yeah,
that's something that comes up.
So anti-affinity rule, my comment about anti-affinity rules is they work great in a large data center. They do not work at all if you only have a couple racks, or if it's at the edge. They literally don't. They're completely moot. So they do work better at larger scale, but yeah, we turned them off because a lot of our sites were too small to really take advantage of them.
Yeah, they certainly work better when the cloud is empty.
All right. I have popped in, Beth.
Yes, that's fine.
That means that I think we're wrapping up, if you're good with that.
Yeah, it was great conversation. And we only got, as I said, about 1/3 of the way through the question. So that's always a good sign, right?
Yeah, the Etherpads will stay up. There's lots of opportunity to keep collaborating after the event, which is one of the things we aim for here, is to get people connected, figure out what the topics are, and then keep working for a long time after. Awesome. Well, thank you so much to Beth and everyone. We had so many great comments and great engagement on this topic. So we're going to take about a 10-minute break. We really cut the break super short last time, so we're going to try to go for a full break here. So we're going to come back at 10 minutes past the hour, so it'll be about 9 minutes, but that'll be a nice break. So Aaron, if you want to roll the break slide and the amazing music that you've selected for us, we'll be coming back for the next session here in about 9 minutes. All right. Thank you, everybody. Enjoy your break.
All right, hi everyone. Hope everybody had a great break. We're ready to bring it back now. And I would like to introduce Masahito, who will be moderating the software stack topic discussion. We'll be throwing up an Etherpad here. And then I'll let Masahito take it away.
Yeah, thank you, Ashley. Can you hear me without any noise? Yeah, sometimes my mic makes a noise. So.
There's a little bit of noise.
Okay, I will change the mic. How about this?
That's great.
Sounds good. Okay. Okay, I will share the Etherpad page. Okay, can you see my screen?
Looks good.
Yep.
Yeah, okay. So thank you for joining the software stack sessions. I think this session is the first effort in the OpenDev Summit for I think so. The no specific direction for this session right now. So feel free to talk and write any topics and any idea, comment, and thought. And so and please write your names if you want to join in the discussions. Yeah. So I wrote few topics for that. And before starting the topics, this software stack session will cover entire your system software stack as well as the OpenStack. So we don't need to stick to the OpenStack OS, OpenStack software, but we can talk about the OSS software, open source software for that software stack. And I wrote it few topics related to these software stacks. So first one is about how the software stack changes considering the size of the deployment. Like when you make your deployment, the bigger how the software stack was changed with that scaling or something. And I put few perspective for that scaling and software stack. First one is deployment and network, and second one is deployment and testing, and the other one is the application delivery. So yeah. And also I think we will have one voting for the software stack about what point did you feel that any difficulty for your software stacks? So please vote the voting. Yeah, please vote, and then I think we can share the difficulty of our software stack with others. Yep. I think as the previous discussion, you can unmute yourself, I think. So if you have any comment, please raise a hand or please talk something.
Yeah, Prakash here. I would like to comment on the software stack having changed, mainly because baseline today, folks consider that you have your Kubernetes cluster as the base. And even the OpenStack goes into the control plane as one of the stacks. So
yes.
Kubernetes has changed more, not just being a container orchestrator, it has become a state machine basically now. So you have a state machine which is underneath and which is trying to deploy everything else in the control plane. Could be OpenStack, could be what you call the OpenShift, or could be any of the cloud controllers for the control plane. So there is a perception as well as a change in the software stack being containerized. It's becoming more and more common to assume that you are going to get either integrated OpenStack you want to install, or you want to just pick and choose some of the modules, but all of them have to be containerized for a large scale deployment. And the next part of it obviously comes that where is the workload? So workload may be containerized, may not be containerized, depending on what kind of cloud controller combinations you are using, multi-cloud as well as hybrid cloud. That's what, when it comes to stack, we have to stop thinking of being a VM-based stack, rather we think of container-based stack. That's what is happening, or at least moving towards, I would put it. That's my comments. Thanks.
Yeah, thank you. So the basing on the applications, you mean we have to change the virtual machine or bare metal virtual machine and yeah, container and without with the container. So so like for telecom application, we should pick the bare metal and the non-containerized or something like that. You mean depending on the application features or characteristics.
So the application is one part of it, but the platform itself is the first issue. See, application is service facing, whereas the system is resource facing. So when you're resource facing, it apparently, when you talk about integrated OpenStack, the first question comes to is, how do I interoperate with bare metal, VM, containers? All is in the play now. So this looks like software stack, smaller units and scalable, auto-scalable versions are better. So obviously microservices is one of those where even all our OpenStack modules, we have to really consider them as microservices, like networking services for VM, compute services with VM or without VM, with just being on containers or in bare metal physical. So the whole concept of software stack is actually it's evolving, and it's a moving target right now. Keeping integrated OpenStack is fine, but we need to look at distributed stack now. That's the reality. Whether we go to the edge, whether we go towards the 5G, or whether we go towards the core, or we keep at the edge, far edge. So it's a challenge at this time because software is evolving, and nothing, we would say that I don't see that OpenStack will remain as is, as of current stack, how it is. Maybe 5 years since it will be totally different and distributed with different way of looking at it.
So the first, when we talk, sounds like when we start to talk about software stack, we should classify the areas or the size of the software stacks, like for the edge and for edge and the data center or something like that. Before we are talking about the deployment or application delivery or any these stuff. Is it your comment?
Sure. So we do have the edge architecture, which our edge group has put out. Certainly, it does bring small, medium, large, and numbers, but so thousands and larger would be thousands and 10,000s and 100,000. You can count in terms of cores, you can count in terms of the nodes, you can count in terms of. So yes, there is a sizing, and definitely, but at the same time, sizing in terms of units, number of units, even if you look at the various other industry initiatives like CNTT, they do have a block. So there is always modularity of scaling. So even if we classify them, still we have to talk in terms of units, whether we want to have 1,000 VMs or whether we want to have 10,000 VMs or 10,000 containers, 100,000 containers, million containers, and how many nodes. So the topology is varied, but the units still matter. Units need not be as big, because we always assume that we are going to get a horizontal scaling.
Okay. So I got it. Your point. I think the first we have to clarify the size of the software stack, size of the infrastructure we target, and I think this OpenDev session is for the large scale. So I think that if it's okay, so I think we can talk about the large scale size, the software stacks first. And sorry, I'm not familiar for the edge cases, size of edge. So
Yeah, Masahito, I think that you make a good point of thinking about large scale software. And one of the questions that was in the Etherpad was on line 43 around deploying on virtual machines or bare metal, and with containers or without containers. I know that as we have talked with users and looked at some of the data from our user survey, we've definitely seen like bare metal adoption has grown. We have a topic tomorrow, I think, about around bare metal specifically, but I'm curious, what people are doing on their software deployment front. Are they, there was a while where it was like virtual machines were definitely the preferred mechanism for deploying software stacks on top of clouds. Is that moving to bare metal more, or containers and virtual machines are still heavy on virtual machines? I think that's an interesting one that I would love to hear any feedback on from people.
Thank you, Jonathan.
I can just throw out there that, from our perspective, it's still been virtual machines as a base. I mean, the cloud's obviously bare metal underneath, but everything is the cloud itself is all containerized, and then applications within the cloud are more often becoming Kubernetes-ish, OpenShift generally, but all that stuff runs on top of VMs and is spawned and scaled by heat stacks. So it's kind of adding another layer to the onion, but still VMs involved.
I mean, it could be interesting to run a poll on whether people use VMs or bare metal or containers as the base for their deployments, and also whether that changes based on the size of the deployment. So I'm not sure we can actually do that through the poll system that we have, because
you want like a two-dimensional poll.
Yes, it's two-dimensional.
Maybe use Etherpad.
Maybe the
Cool,
Etherpad,
that'll be
like
cool.
if people could give a sense of whether they're engaging with they're starting deployment using like a VM based deployment solution, and then switch to bare metal, or more bare metal driven by infrastructure, bare metal, pure bare metal, or container type deployment like Cola or OpenStack Helm. I don't know if that's
there's a list of tools. There's a list of deployment tools down below. I think, where did it go? Line 132, with a bunch of deployment tools listed out. People could +1 what they're using for deployment on there, and we can do like a custom containerized, custom bare metal, something like that. And if I forgot, I didn't list all these out. So if somebody's got deployment tools, but you can just +1 next to what you're using. And that would kind of give us an idea of whether it's containerized or bare metal or other.
You mean in Etherpad?
Yeah, on the Etherpad.
Which Etherpad are you in?
Yeah, you might be in the wrong one.
Oh, maybe I am. Oh, sorry. Maybe I am.
We'll drop it in the chat.
Okay, I'll find it. Yep. Well, we can just put one there. I can put it in there. I might have put it in the wrong place. I'll be sorry.
Is it for the tools, Etherpad?
I'll just copy it into the other one. That was the right one. The link you just put in the chat, line 132.
We're actually in the one that Allison put in, the large scale software stack.
Okay,
that's
the other one that I was already into the chat. So sorry.
Dueling Etherpads.
There we go. Yeah, that's 2 Etherpads for 1 session is not good. Okay. Yeah, somebody's got it already pasted in there, so that's what I added to. That's fine.
I don't mind talking a bit about some of the contrasts we've had between bare metal usage and VM usage. I think it's interesting because it does mirror some of what we spoke about in the previous session about how much the application is ready for failure. So we spoke about the need for, like, if you do have those 2 switches, it means you can fail over between them while you're doing the firmware upgrade. It's kind of similar. If you take the cost of VMs, then you've got the ability to do host upgrades without affecting the applications in your cloud and firmware upgrades on those hosts. Whereas it's obviously a bit different if you take the bare metal route. I don't know if people have seen other contrasts. So it depends on your application, like whether that VM tax, so to speak, is a big deal. Certainly in the HPC world, where there's an awful lot of customers that are very used to getting every last ounce out of their bare metal machine, so they tend to be happy to to take the hit of knowing that bare metal machine is an individual machine, and if it dies, it dies. I don't know if people are seeing other similar patterns. So I guess in the OpenStack sense, like underneath, we're kind of using Ironic to do the deploy, but we're also, once you've got the hang of doing that Ironic for your hypervisor deploy, also allowing that for customer deploys. But obviously there's a security concern there in terms of securing that bare metal machine. I don't don't know if people are seeing the same trade-offs or if they've got fixes to that security problem.
From what I've seen, the VM-based deployment solutions are losing steam, and it's more of a game between, like you said, a container-based deployment for convenience, or a bare metal-based deployment for high, like a high performance, not losing anything. And it's probably a good sign that we've facilitated the deployment through the various tooling that we've produced as a community. I don't know if there is anyone still using purely VM-based system for their deployment. I haven't seen. Most of those are more.
CERN is still VM based, aren't they?
Which one?
CERN? So if they were saying yesterday, somebody was, Belmiro was saying yesterday that they're still running virtual machines for their control plane, I think.
Yeah.
I think they said they're transitioning as well, although maybe he can answer. I guess I should say I was talking more about the workload, not the control plane. The control plane is bare metal with containers, because of Collar Ansible and KB, but for the general case that I'm seeing, I'm more talking about the workloads that the users are running on there. Where Kubernetes runs, it depends on where they want to put that. Sometimes the dynamic nature of, so people want auto-scaling Kubernetes clusters, and the bare metal create time is so long that they prefer the VMs for that flexibility and able to spin up, spin down quicker. So cluster autoscaler within Magnum works quite quickly with VMs, but when you have the whole, it takes 5 minutes to get through the post process for the bare metal machine, it can take some time.
To come back to the initial question, which was, is the technical choice changing based on the size of the deployment? I feel like between the container and the bare metal systems, both are equally suitable for large scale. It's more a question of the trade-offs you want to make in terms of performance versus convenience or flexibility. Is that a fair statement, or is there like a more of a container-oriented type of deployments when the scale goes up? What's your experience?
I'm happy to share some things that I've seen. Certainly what I've seen a pattern of is that while everything Thierry said is true, there tends to be more, at the larger scale, there's more sense for people to have specialisms. So for those, people have those difficult workloads where they can only run on bare metal. So at the larger scale, there's more of those that are a problem. So they tend to have to deal with that in a more systematic way. So it forces them to worry about, actually dealing with a bare metal case. Where if there's not so many of those shouty people, you can get away with a slightly more generic solution of the VM. But maybe that's a special case for the environment I've been in.
So Tom Barron in the Zoom chat put an interesting comment about Manila, and I think this is we've sort of maybe bounced back and forth between talking about the deployment of the applications running on top of an environment versus the deployment of an OpenStack environment. But he says that in Manila they're designing for storage consumption equally by containers, virtual machines, and bare metal nodes. Thinking this is a dynamic area and it's a mistake to make restrictive bets. So from the workload perspective, designing for usage across containers, VMs, and bare metal is, I guess, is the path that Manila is taking, rather than making too much of a bet right now on everybody going back to bare metal or sticking with VMs or moving to containers.
Yeah,
I
if
think
if I were to make a bet, I would bet that lots of application users will be running in container orchestrators, Kubernetes specifically, and that Kubernetes will be running on different cloud providers, including OpenStack. And that on OpenStack, obviously it'll run on Nova VMs. You'll use Nova VMs, but we'll see increasingly interest in running it on bare metal there, so that you would have hundreds of different Kubernetes clouds belonging to, typically smaller sub-organizations. I'm thinking more private cloud than public cloud case, but it's almost like public cloud, the self-tenant, self-service multi-tenant type of OpenStack. But that's a bet. I could well be wrong about that. And so, yeah, we want Manila, which is consumed over a network, to work in all of these, and we're making sure it does. You mentioned the deployment side of it, and there the important thing, I think, is that for this service, it can run very well with all the other OpenStack services, or it can run more or less standalone. It runs in containers today as well as on bare metal. So different orchestration possibilities are possible for running the service in terms of, do you have a Kubernetes based deployment tool? Do you have something like heat stacks and that deploy with containers, which is what my company does today. But again, just trying to maintain lots of degrees of freedom and modularity for that kind of thing. I don't know if I'm responding appropriately, Jonathan, but thanks for bringing it up.
Yeah, no, that was great. Thanks for chiming in.
Okay. So before moving forward, voting will finish in a few minutes, I think. So please vote if you vote yet for that. What point do you feel difficult in your software stack? Yeah. So sounds like the for the bare metal or the VM, the discussion sounds like we have based on the workload or the applications, the characteristics. We decided which we will use for which bare metal or VM we will use, and then we will stick to that ways in the future. That some and for my experience, actually we are using we have the local bare metal and virtual machine in our cloud. So when we using the bare metal and virtual machine, we have some issue for the access controlling problems for auto scaling or scale out. Yeah, so I put the topics here at line 45, 54, but sounds like is there any no access control issue for that your software stack? Is there any access control issue for that in your software stack?
We are all reading what John is typing now.
Thank you.
I should say it really, shouldn't I?
Type faster, John.
I was trying, but then it gets even more illegible. So I'd say one of the things I've been seeing is that application credentials have made a big difference in terms of access control. This is very OpenStack specific, right? But in terms of providing credentials to the Keystone API, in recent releases, you can now create OpenStack, you can create application credentials and use those instead of your username and password. The great thing being you can delete them and revoke them at any time. You can also give them a subset of your roles, and you can start, I think I haven't actually tried it out in the latest releases, but I think you can actually start to restrict which URLs that application credential has access to. But the reason I was interested in this is actually because certainly in the HPC and scientific computing case, there's an awful lot of push for people to bring their own credentials to applications. So it's specifically what that means is that when you're logging into OpenStack, or indeed the application is running on OpenStack, you use your usual work account to log in, SSO or whatever, but you don't want that very valuable credential being used for autoscale, as you rightly said, Masahito. I don't want to put my I don't want to put the thing that can get hold of to book holiday for me in an automated script to do that. And application credentials kind of gives you that middle ground. I don't know if other people have played with that.
Oh yeah. So when you scale out the bare metal servers with bare metal or virtual machine with Magnum, I think is there, do you have any DBACL or something like that for that applications? Because even for the OpenStack deployment, when the old scale out with Kubernetes, it might hit the ACL issues for the DB or something, DBACL or some things. I think that if I missed the technology which allow to outscale the DBACL stuff with the Kubernetes outscaling or something, that I think we should start to use that. But
yeah, I can certainly say I've seen some good success using the Magnum Kubernetes autoscaler in terms of, so your workload inside that is doing horizontal pod autoscaling, which puts pressure on the Kubernetes cluster to decide it needs new cluster nodes, and then Magnum could provide those extra nodes. Although underneath that, in terms of access control, I guess that's all using trusts right now, as I understand it.
like okay, thank you. Is there any comment or your idea for this one? If nothing, then we can move on to the next topics.
Before moving, Prakash here, is the Magnum auto-scaling equivalent of role-based access control of Kubernetes? Does it support that? So you have n number of users and therefore it auto-scales itself for allowing additional spawning of new cluster or containers? I'm confused here based on what the access control is mentioned here. Maybe you can help me, or we can talk offline later.
Okay, so from my point, I put this access control from the application run on the Kubernetes or the any virtual machine or bare metal stuff, which can be managed from the API, OpenStack API, to any other applications, to the other application, maybe like a database for some applications or database for somewhere else. Yeah, something like that.
Yeah.
So I guess if we're talking about access, yeah. So for Kubernetes, talking back to OpenStack in terms of access control there, certainly the credentials that you give a scope to the project in the usual Keystone RBAC sense, if that makes sense. So an example, so generally you're giving Kubernetes in a particular namespace, or generally across namespaces, you enable some functionality that requires OpenStack credentials. So for example, if you've got the OpenStack provider creating load balancers on your behalf, generally you just give that, you give access to that functionality through a particular user. That certainly works. Maybe we want to move on.
And yeah. Can I interrupt that conversations? We got the result of the voting. Can we copy and paste that result to the Etherpad or not? Okay, with it looks like in the software stack we have the issue on the networking first. And second is deployment. Yeah, so if someone does something, someone to talk about the networking issue difficulties or deployment difficulty, that's okay for talk. If not, I think we only have maybe 10 minutes left, so we can.
On the deployment, that's interesting. You know that deployment was the second highest option there in the poll. Is that deployment? There's some information around like development and testing and application delivery, which are all kind of deployment related. So I'd be interested to see what people are using there or challenges they're having with those topics as well.
Yes. So okay. So let's move on to the development and testing. Development quickly then. So looks like no one.
Question here is, does it make allocation, reservation of resource for the scaling in the access when you mention, or is it trigger for scaling? Simple. It's just an alarm or a trigger.
Sorry, but for what?
No, when you say auto scale and access while accessing, if you find something you need to scale, does it mean it's a trigger for allocation or is it a alarm for scaling? What does that indicate?
I think this is the comment that John had put in on line 58.
Yeah, maybe. I was wondering if that was a question to me. I can go through what that actually does. So an interesting example, because you were bringing up users logging in. One particular application that I've seen a lot make good use of this is Jupyter Hub. The general idea is that as a user logs in, if they're authorized, it spins up an extra container and sets of environments for that particular user. If you're using things like Pangeo, you've got a whole load of Dask workers it spins up. So anyway, there's an action that triggers more containers to be required within the cluster. Another example is that you might be using the horizontal pod autoscaler, and that uses a whole heap of reasons why it might decide to scale. Now, I think out the box, what the Magnum autoscaler is what cluster autoscaler within Kubernetes is actually doing is really looking for the case where you could no longer start any more containers. So, the containers that you request go into the pending state. It detects that and then triggers the auto scaling. So generally that's if there's not enough CPU, enough memory to start that container, given the request for that particular container. So it depends on the application, but fundamentally, where I've seen the Magnum cluster autoscaler do the best things is where, for whatever reason, the application spawns more containers and then room is made for those. And the system does have like back off pressure to stop it flapping between tearing down VMs and recreating them again. Does that help answer your question?
Yes. If that.
Yes, I meant.
Okay. Thanks, John.
Okay.
So if possible, if possible, we want to jump onto the next stuffs a little bit, development and testings. So like for development and testing sections. So I think all of us who are running our cloud or our application, we have some gating the mechanism for our deployment, our cloud. So in the Etherpads, no one writes anything in the just so but I hope if someone use any gating mechanism for your application, please write your ideas. And as for the testing framework is as well. Please put your idea on the Etherpad or that how can I say that share your thought for that stuff. So in our case, in line case, depending on the project, but for us, we use the Jenkins for the gatings basically, but for the others, the continuous integration, we use the drone CI and drone CI for building the applications and testing for our OpenStack code internally with custom code. Yeah. And actually we thought that we introduced Zoo-like gating system, but first it takes times for introducing the architecture, so that we are not using the Zoo right now, but yeah. And Prakash, are you speaking something?
Yeah. Okay, I can speak.
No.
In the airship we do use a combination of Zool and some of them, because they go to Metal Cube, we do see some testing using Prowl or something, PROW Pro. So yes, there are variations, whether it's Jenkins or Zool or sure. Thanks.
Yeah, sorry. Thank you. The in Doom chat, your names is colored yellow, so I thought you were talking something. Yeah, thank you. And looks like no reactions for the deployment. No deployment for the gating stuff. So does everyone use Zoo right now?
Yeah, for OpenDev, yes, Zool is the option we have. We don't go for Jenkins, but yes, some of the other OPNFE folks do use Jenkins still, and also Nordics. That is, EU folks also use Jenkins.
And for testing stuff, looks like we have the someone use Rally, Tempest, and I don't know the third one, Cloud Buster. But
Does anybody know Cloudbuster? I'm not familiar with
Yes,
that either.
Cloudbuster is using is a tool for load testing OpenStack for data plane actually. It's a great tool that you can load test your network plane and the storage plane with different scenarios.
So it feels like those testing frameworks are more for testing the infrastructure side of things, not necessarily the applications that are running on top of it, right? Because Wally, Tempest, and Cloudbuster all test the OpenStack APIs and not the application on top of the OpenStack APIs.
oh, that's nice tool for testing. Yeah, so the three of the testing framework are the majors for the major tools for our software stack. So some, if nothing else, for the other testing frameworks for the software stack, we can move on to the next one, security hardening to complement DevSecOps. I think so. The who wrote that? This line. So okay. I don't know who wrote this, but okay. So. And for the other stuff, let's move on to the application delivery. So but it's already running out of time. So I think it's not a forum session, but if should we have the next work item or something for that session, OpenDev session?
If there's something that comes up and makes sense, then yes. I'm trying to think if there's anything that has popped out in this session.
I feel like we can work on at the large scale SIG as we collect the scaling stories, people ramping up their deployments. When do they consider new tools, or do they evolve the software they are using to run their infrastructure, but also for the applications that run on the workloads that run on top of that infrastructure, and how that evolves over time based on scaling. So far, we've mostly looked into the bottlenecks and scaling issues, but we could also look from an architectural perspective. and see how those deployments evolve over time too as they scale. What do you think, Masahito? Is it an interesting thing to try?
Yeah, that makes sense to me. That as you said, we as large scale things, we are collecting the user story for the problems while we are getting bigger, the cloud size getting bigger. So I think from this discussion we have the point to put the user stories so we can so we can put the time story for the scaling story for the actual name, but scaling story of the large scale thing.
Excellent. Thank you so much. It's been a great session. I think
thank you.
I think we're gonna kick it over to Ashley to give us a quick wrap up for the day. But thank you so much for leading that session. It was great, and we have a lot of good follow-ups with the large scale SIG if you want to get involved there and keep pushing this forward. Ashley, do you want to wrap us up for the day?
Yeah, absolutely. Yes. So thank you again to Masahito. That was wonderful. And thank you to our other moderators, John and Beth. And thank you to everybody who joined today. I think we had people from all over the world, which is very cool. So thank you for staying up super late or waking up really early to join us. We really appreciate it. And we think that this was a great day of OpenDev, and we're looking forward to tomorrow. So again, just we took some cool polls today, which we'll do more of tomorrow. We learned that upgrades are a big pain for a lot of people, and the software stack can be difficult on a variety of levels, everywhere from networking to auto scaling to testing. And so we want you to keep sharing this information with us. Again, you can take the user survey. Allison Price really supports that. She said, please take it, or you will hurt. So please do that. So again, share that, share more in the Etherpad if there's anything that we didn't get to today. Those Etherpads live on forever, so we'll be able to refer back to them. And again, drop your contact information in there, please, if you're interested in connecting with others. And we want to keep this conversation going. So again, we want to direct you to the large scale SIG. That's going to be the best place to continue these conversations. So we encourage you to join that and get involved. We're going to be dropping some of those links in the chat so you can learn a little bit more about those things. And then let us know some feedback on this event. If you have any suggestions for how this event could be smoother, or anything that might add additional value, please let us know. We'll also drop in an Etherpad that links to that. And yeah, I will turn it over to Mark to give us a little heads up on what's going to happen tomorrow.
All right, yes, tomorrow we have some really exciting sessions. Bare metal, this is one of the hottest topics right now. If you look at the different tools for automating the data center, no matter what you're running, higher up the stack, the bare metal automation, there's so much innovation going on there for enabling different types of hardware, looking at the life cycle of all the stuff that you're putting in and out of your data center. It's a really rich space for innovation and sharing best practices. And we have some folks doing it at an amazing scale and also experts on those different tools. And we also have, of course, an edge computing session, another very hot topic these days. Touched on it a little bit today in Beth's session and yesterday as well. So both of those are expected to be really awesome opportunities to engage. So their Etherpads are out there. If you look at the schedule link here, we'll drop it in the chat as well. The schedule link links to the Etherpad so you can look. And I think it really helps if you look at those before we get to the session, start to populate it, or at least familiarize yourself. So if you're wanting to jump in and participate, to unmute and join the conversation, the more you can look at those before we reach that point, the better prepared we'll all be. And then we have a session scheduled for a wrap up of the week, talk about what we've learned and how we're going to work together going forward with these different SIGs and work groups and all the different efforts that are going on throughout the industry. So that's what we have on tap for tomorrow, and that will be our final day of this OpenDev. And then we have 2 more OpenDevs, don't forget, coming soon. So if you go to openstack.org/opendev, you can register for the next 2 events that are also talking about open source infrastructure. And so with that, I'll just say, come back tomorrow and we'll see you then. And that's a wrap. And I hope you all had a good time with OpenDev today. Thank you.
Thanks, everyone.